Okay, we're going to look at solving literal equations. So first we have d equal to rt. And we want to try and solve this for r. That means we want to try and isolate this r. Right now r is being multiplied by t, so to undo that multiplication, we will divide both sides by t. So that gives us that d over t is equal to r. And we have solved for r. Let's look at this equation. P is equal to 2L plus 2W, and we want to solve for L. Again, we're trying to isolate the variable L. So here's our L. Right now it's being multiplied by the 2, and then 2W is being added to it. So we want to undo that process. So first we're going to subtract the 2W from both sides of the equation. Gives us P minus 2W is equal to 2L. And again, 2 is being multiplied by L, so we'll undo that operation by dividing by 2. That gives us P minus 2W over 2 is equal to just L. The 2's would reduce. Now let's look at this equation. I have I is equal to P plus PRT, and we want to try and solve this for P. Now this is different from the previous two problems because we have a P in two places. And our goal is to somehow try and get P all alone. Since it's in these two spots, normally we would try and combine like terms. But because we're dealing with these little equations and we have so many variables, what we'll do instead is actually factor, or you could think about it as undistribute that P. So P times 1 would get us that P. And then P times RT would get us PRT. So if you think about distributing, just to kind of double check what's going on, we would do P times the 1 plus P times the RT, which gets us P plus PRT. So really we're just undistributing or factoring. So once we have that, we now have P in only one spot times this 1 plus RT. So if we want to undo that multiplication, we will divide. So we'll divide by 1 plus RT on both sides of our equation. That would make those reduce. So we end up that P is equal to I over 1 plus RT. Let's consider this equation. We have Q equal to 3A plus 5AC, and we want to solve for A. Now we're looking at this equation. It's kind of similar to the last problem. We're trying to solve for A, and we have A again in two spots. In normal equations, we would try and combine those terms together. However, because it's a literal equation and we have some extra variables going on, it works best to undistribute that A or factor it out. So A times what would get me 3A? We would need 3. A times what would get me 5AC? We would need 5C. Now the A is just by itself here as only one A. We would like to undo the multiplication by the 3 plus 5C, so we'll divide both sides by 3 plus 5C. That gets us that Q over 3 plus 5C is equal to A. Let's consider this equation. We have AX minus D is equal to B minus C times X. And we want to try and solve this for X. When we look at this, we have an X term here and an X term here. They're on opposite sides of our equation. So before we would try and factor it out. Now it doesn't make sense to do it here. Instead we'll want to try and put our terms on the same side of the equation so we could then factor it out. So I'm going to try and move the CX over to the other side of the equation. So I will plus CX and plus CX. That gets me AX plus CX minus D is equal to B. So the stuff just follows down. Now we want to try and get X by itself. So I would move the term that doesn't have an X to be with the other term without an X. So I have AX plus CX is equal to B plus D. Now that I have all my x's on one side of the equation, it's still in two spots. So we'll undistribute or factor like we did before. X times A gets me AX. X times c gets me xc, and this is equal to b plus d. Now x being multiplied by the a plus c, so we'll undo that by dividing by a plus c on both sides of the equation. So we end up that x will be equal to b plus d over a plus c. Now let's look at this. We have ax plus by is equal to c times d plus x. And again, we're going to try and solve for x. This is similar to our last one. We have an x on both sides of our equation, but the problem is that the main operation on this right side involves the multiplication of c times d plus x. So before we can try and put our x on the other side of the equation, we'll distribute that c. So we'll end up with c times d, that's cd, plus c times x, that's cx. And we have ax plus by still on the left side. Now since I have the x's on each side of the equation, I'm going to try and combine them together. So I'll move that cx over. So I have ax minus cx plus by equal to cd. So these are still just following down. Now since this term does not have the x in it, I'm going to move it to the other side by subtracting. So I have ax minus cx. Those cancel. We get cd minus by. Now these terms both have the x in it, and I can't actually combine them because of the variables a and c. So what I'll do is I'll factor that x out. X times what gets me ax, that would be an a. X times what gets me cx, that would be c. This is equal to cd minus by. So again, x being multiplied by the a minus c, so to undo that, we'll divide by a minus c on both sides of the equation. So then we end up that x is equal to cd minus by over a minus c.